Hello sir, my name is Atam Das and I am currently pursuing MSc Mathematics from IIT Patna. Today I am discuss the important topic arithmetic progression, which is which is a part of the sequence of series. Arithmetic progression, also known as by AP, and the definition of arithmetic progression is the arithmetic progression is a sequence of the number in which we keep adding or subtracting to get the next term. The fifth term called the common difference, which is denoted by D. Let us suppose A is the first term, and if we add some constant number D, then A plus D become the second term. A plus D become the second term. Similarly, if we add again the D, then A plus 2D become the third term. Similarly T4, T5, we can see that T3 equal to A plus 2D. We can simplify and we can write A plus 3 minus 1 into D, and this is the third term. Then there is 3, and similarly we can write T4 equal to A plus 4 minus 1 into D, and similarly T5, T3, T6 and so on, and Tn equal to A plus n minus 1 into D. This is the to find the nth term. This is the formula, and now we find the sum of nth term, which is included by Sn. Sn equal to n by 2 into 2a plus n minus 1 into d, and we can simplify n by 2 into a plus n minus 1 into d. We know that a is the first term and a plus n minus 1 into d is the nth term, which is the last term. We can also write first term plus last term and multiply half of total number. This is the formula of Sn. And now I am discussing the some properties. First, Tn equal to, for any sequence, Tn equal to Sn minus 1, and now I am moving to prove these properties. We know that Sn equal to a plus d plus a plus 2d plus and so on, a plus n minus 1 into d, and Sn minus 1 equal to a plus d, similarly, and so on, a plus n minus 2 into d, and we can subtract equation first and equation 2. Equation 1 minus equation 2 equal to Sn minus 1. Every term will be cancelled. A cancelled by a, and a plus d cancel. Similarly, a plus 2d cancel, and remaining term only a plus n minus 1 into d, and a plus n minus 2 into d will be cancelled. Only remaining term a plus n minus 1 into d, and we know that we can write this is the Tn term. We know that this is Tn term. Then Tn equal to Sn minus 1. Hence proof. Property number first. Hence proof. Now I am discuss the second property. Property second. D equal to Sn minus 2 Sn minus 1 plus Sn minus 2, and this is the property 2. Now I am going to prove these properties, and we know that every consecutive term, difference of the every consecutive term will be constant. Difference of every consecutive term will be constant. T2 minus T1 equal to D, and T3 minus T2 equal to D. Similarly, difference two consecutive term will be constant, and Tn minus 1 equal to D. We can write D equal to Tn minus 1, and by property first we know that Tn equal to Sn minus 1, and similarly we can write Tn minus 1 equal to Sn minus 1 minus Sn minus 2, and we can put value. We can subtract Tn minus 1 equal to Sn minus 1 minus Sn minus 1 minus plus Sn minus 2. Sorry, 2. This is 2. Sn minus 2. This is 2 Sn minus 1, and D equal to Sn minus 2 Sn minus 1 plus Sn minus 2. D property having hence proof. Now I am discussing the property number third. Third property is A1, A2, A3, An is in AP, and if we add a subtract some constant number in every term, then this is also in AP. If we add a subtract some constant number, for example, m is the constant number. If we add some constant number in every term, then it is also in AP. An plus minus m is also in AP. So in AP. Okay, and if we multiply by some constant number, it is also in AP. For example, m A1, m A2, and so on. M An is also in AP. Okay, now I am discussing the property number 4. Property 4. Property 4. Mth term. Mth term from last. Mth term from last is equal to n minus m plus 1 th term from first. Both are equal. Mth term from last is equal to n minus m plus 1 th term from first. Both are equal. Okay, and let a example. Let us suppose t1, t2, t3, t4 and so on, t10, t9. Let us suppose total number is 10. Let us suppose total number is 10. Then setting term from last. Setting term from last is equal to total term minus mth term यानी setting term plus 1 th from first. Then from last first, we can see that this is the first term from last, this is second term from last, and we calculate 9 term by in general, and similarly we can see that in the by formula 10 minus 2 is equal to 8 plus 1 equal to 9th term from first. Both are equal. Now I am discussing the property number 5. Property number 5 is very easy, and we can see that let a1, a2, a3 and a100 is in AP. Let us suppose, and the first term and the sum of the first term and last term and second term and now I am discussing the property number 5. Property 5, let a1, a2 and so on, a99, a100 is in AP. Let us suppose, and the sum of first term and last term and is equal to sum of second term and second last term. The sum of first term a1 plus 100 is equal to sum of second term plus second last term A99 is equal to similarly sum of third term and second last third term, and similarly they are equal, and A25 and A26 they are equal. Now now I am take an example. Now I am take an example. Let 1, 2, 3 and so on 100 is in AP. We can see that the difference of two consecutive term will be 1, and this is in AP. Then the difference d equal to 1 and first term equal to a equal to 1 and last term equal to 100, and the sum of first term plus last term, first term is 1 and last term is equal to 100, then they equal to the sum of the first and last 101, and similarly the sum of second term and second last term 2 plus 99 is equal to 101, and similarly 25 plus 50 plus 51, 50 plus 51, 50 plus 51 is equal to 101, and the sum of the first 100 natural number is equal to 101 into, this is the 50 times, then we multiply by 50, then answer is equal to 505 50505 550. This is the answer, first 100 natural number. That we can see that sorry, here is 50, sorry, here is 50 and here is 51, here is 51, sorry, this is my mistake, 51.